Hello everyone, good afternoon. I am Jair Khan, final year master student in the Department of Computer Science at IIT Palakkad. My fellow co-authors are Dr. M. Sabarimalai Manikandan, Associate Professor in the Department of Electrical Engineering at IIT Palakkad, and Dr. Mufti Mahmood, Associate Professor in the Department of Computer Science at Nottingham Trent University. Today, I am going to present our paper named as Photophotosmography Signal Quality Assessment using Neighbor Edge Restricted Horizontal Visibility Graph and Machine Learning Classifiers on 16th edition of International Conference on Electronics, Computers, and Artificial Intelligence. So here is the contents I'll cover. First, we will see the introduction of PPG signals and horizontal visibility graph algorithm. Neighbor Edge Restricted Horizontal Visibility Graph algorithm. And after that, we will see classification approach and the results. And at the end, we'll conclude our work. So PPG signals PPG is a simple optical technique used to detect variation in blood volume using an optical method, which offers insight into blood flow changes in a non-invasive way. And PPG signal is important, which gives us vital signs like pulse rate, blood pressure, and many more things. But the problem is PPG sensors are usually positioned on the non-invasive parts of our body like the arms and the fingers. Because of this placement, there is high chance that the signal will be motion artifacted or degraded. So here you can see this signal segment is motion artifacted or degraded. We call this kind of signal as noisy signal, and this one is very high quality signal. We call this kind of signal as clean PPG signal. From this clean PPG signal, we get the accurate medical diagnosis, but in case of noisy signal, we don't get. That is why we need to classify PPG signals into clean and noisy. So here is the horizontal visibility graph algorithm or HVG algorithm. HVG algorithm is a variant of visibility graph which converts a time series of n signal values into a graph of n nodes. So we'll understand HVG algorithm through this toy time series example. You can see here there are 15 time indices from 0 to 14, denoted as 0, 1, 2, up to 14. And corresponding to this time series indices, we generate nodes of the graphs denoted as 0, 1, 2, up to 14. You can see here these signal values can be joined using a horizontal line. They are visible to each other through an horizontal line. That is why these consecutive nodes 0, 1, 2, 3, 4, they are joined through the edges. But in case of non-consecutive signal values like this 9th and 11th, if you want to join these signals using an horizontal line, that line will be intersected by an intermediate signal value. That is why we have not joined this 9th and the 11th nodes through using an edge. So that is how actually HVG algorithm works. Here are some literature survey we have done. The authors have used visibility graph and machine learning techniques for their study on biomedical signals like PPG, ECG, and EEG. And they have got very good accuracy, which has motivated us to use visibility graph algorithms and machine learning classifiers for our PPG signal quality assessment study. So here is a proposed algorithm, Neighbor Edge Restricted Horizontal Visibility Graph algorithm, or any RHVG algorithm. We have noticed that clean segment of PPG signal values are monotonically increasing or decreasing in some particular interval of time domain, almost periodically and uniformly. Whereas this kind of properties are not seen in noisy PPG segments. So we have tried to integrate this information into our visibility graph algorithm. So here you can see this time series signal example. We have joined this consecutive signal values through an horizontal line, but in case of uh, this pair of signal values, we have not joined because the signal value differences between them is greater than a certain threshold value. So if the signal value differences is less than a threshold value, then we will join the signal values using an horizontal line, neither we will not join. That is the core idea of our proposed algorithm. So according to our proposed algorithm, first we demean the signal values, and during joining the neighbor signal values, we check the signal value differences between them. If it is less than alpha j, which is a threshold value, then we join the nodes j and j plus 1 using an edge. We call this alpha j parameters as neighbor visibility threshold parameter or NVT parameter. To determine these NVT parameters, we have find an algorithm. So according to that algorithm, we first find the zero crossing point, which you can see in red color. In between zero crossing points, we find the peak points. After that, we find the NVT parameter values using this formula. So here is here you can see some graphs which are extracted using HVG and NERSVG. So you can see HVG clean and HVG noisy graph have no such structural differences. But in case of NERSVG clean and NERSVG noisy graphs, there are a lot of structural differences. In NERSVG noisy graph, there are a lot of graphs components you can see. But in case of NERSVG clean graph, there are very few components. Now we'll see the classification approach. So we have used the graph feature average degree or AD for the graph corresponding to signal segments extracted using HVG and NERSVG algorithms. And we have labeled the feature as 0 and 1. 0 is denoted for clean segments and 1 is denoted for the noisy segments. And after all, we have used the machine learning classifiers like Dicicenti, random forest, and Gaussian naive Bayes. So we have plotted the average degrees of HVG graph, and these orange colors are actually corresponding to these orange color points are corresponding to noisy average degree, and these blue colors are corresponding to clean average degree. So in case of HVG algorithm, you can see they are not separable, but in case of NERSVG algorithm, you can see they are separable. So that is the robustness of our proposed algorithm NERSVG over the HVG algorithm. So here is the small demonstration of our classification approach to this diagram. So first we convert PV signals into graph using HVG and NERSVG algorithm, and then we extract the features, and then we do validation and training of the models, and we then find the best trained model. After that, we evaluate our trained model on unseen test databases. And we have used these 5 training databases for the training of our model. And for evaluating our model, we have used these 4 unseen testing databases. And for evaluating the performance of the models, we have used the performance matrices, sensitivity, specificity, and accuracy. Here is the result of our models. This table represents the performance comparison of HVG and NERSVG algorithms. for PPG-SQA. So you can see here these bold values are corresponding to actually the any RSVG algorithm associated with the machine learning classifiers. So you can see in every databases, any RSVG algorithm associated with the machine learning classifiers like GNV has given the maximum accuracy than the HVG algorithms associated with the other machine learning classifiers. And this table presents the performance comparison of HVG and NERSVG for PPG-SQA in terms of overall accuracy, processing time, and model size. You can see all the NERSVG based method has given the maximum accuracy than HVG based methods. And the maximum accuracy we have got from the GNV NERSVG model, which is 92.42%, and it has only 0.609 KB size. So in conclusion, we can say that any RSVG algorithm's performance depends on the defining of the visibility threshold value parameters. And we have seen that any RSVG algorithm has outperformed the HVG algorithm, and GNV NERSVG model has given the 92.42% accuracy, which is maximum among all the models, and it has very less size, that is 0.609 KB, which is the smallest one. So this result shows the robustness of our proposed algorithm, NERSVG. In future direction, we will extend our research into other biomedical signals like ECG and EEG using our algorithms, and also we will use other models like graph neural network and convolutional neural network. So here are the references which we have used. Thank you.